I'd like to thank DDN for their sponsorship of LUG. This next presentation is a vendor presentation from them. The presentation is going to be given by Robert Triendl. He's the general manager for Japan at Data Direct Networks. My experiences with the guy have led me to believe that he's serious and he gets things done. So please, come here, get serious, and get things done. Robert Triendl, ladies and gentlemen.
Thank you, Steve. Yeah. This is a vendor presentation, I'm sorry, so if you don't believe me. Okay, so my experience with Lustre is mostly confined to one country, this is Japan. Also, I'm now also involved in Lustre efforts beyond Japan. And I'd like to talk a little bit about that experience. When I started with Lustre about 5 or 6 years ago, there were probably 2 installations in Japan. Today, Lustre is clearly the undisputed file system of choice for HPC, even for very large systems. I remember discussions 6-7 years ago with the Riken Institute about adopting Lustre, and somehow it did happen. And it certainly is the file system of choice for applications that generate very large data sets, but relative to the size of the data set, a limited amount of metadata traffic. I remember a recent presentation by Satoshi Matsuoka, where he compares his cluster to sort of the global internet, but you know, the comparison in some way, if you just look at throughput, yes, but you know, then look what's going on the global internet. So these are not things that you can compare. The alternative solutions do exist, but they are typically expensive or proprietary, or they don't work, and they are typically not as scalable as Lustre. Now, I try to, as I said, I know the market in Japan really well, and I try to use it sort of as a benchmark for the reality. I try to compare 2008 to the situation 2013. I think I know any Lustre installation in the country from 2 OSSs to, 3,000 OSSs at the Riken. And if you compare what happened in terms of what Lustre is used for, there isn't that much that is changing. So in 2008, there were like 3 systems, maybe 5, but in that range. I would say 40% of them used for really traditional HPC work, but then you had a lot of people using Lustre for already genome analysis, so really more like data analysis type of workloads that are really different. And I remember 2 web companies that were experimenting with Lustre at that time. In 2013, the web companies are basically all gone, doesn't exist anymore, maybe somewhere in the basement. Then there are some people who are using Lustre now as an archive, or at least as the second tier. Not a lot of sites, but a few. And it's about the same mix of sort of research data analysis and HPC work. And then there is a new one, which is a few corporate sites that use Lustre. These did exist in 2008, but they were really small and very specific, and people are already sort of starting to throw out their initial HP deployments with Lustre. Now, looking into the future, and I was just trying to plot how the situation will look like 5 years from now, and I don't think we'll see a huge change. But the area that will probably expand a little bit is actually relative overall is the research data analysis side, as well as the HPC work sort of corporate environment. And maybe a little bit the business data analysis. And the first proposals was Hadoop on Lustre, or sort of special environments that people are looking at. Now, as I said, what happened, so the Lustre market did expand significantly from a few small players to the dominant HPC companies adopting it and the dominant HPC file systems, and from tens of OSSs to hundreds or thousands. But also, Lustre today really is HPC, and a few years ago there were still people trying to use Lustre in different environments, but that sort of, it may have been experiments, it may have been a vendor like HP talking people into doing stuff that they didn't really know what they were getting into, but that has mostly stopped today. Now, if you look at the overall storage market evolution, what really happened over the past 5 years is this whole explosion in software-defined storage that is replacing traditional storage architectures in the cloud, and there are many, many Lustre alternatives that are available or becoming available, and I don't need to list them up, you all know what they are. Lustre remains a little bit exotic and in these areas and is rarely really considered even an option. Now, that is the reality, and I do think that the Lustre community needs to find a way, and maybe a better way, to get back to a broader market step by step. And what I would like to do in the remainder of the presentation, just indicate a few ideas of what, this being a vendor presentation, what we at DDN are trying to do in this area. So I go back to what I showed before, sort of a vision of what the market will look like in a few years from now. And I can actually map projects inside DDN or that are done in cooperation with end users or partners like Intel around these various markets. So in the work area, there is a lot. I mean, we just heard a lot about caching at various layers in the I/O paths. We heard a lot about client performance improvements, about large I/O patches, and something that I would call cluster integration, so integrating Lustre better into a cluster environment from a management perspective. If I go to the research data analysis side, one thing that we are doing right now is the project Quota project that was discussed. This is an area that we are starting to look at, sort of small file I/O, acceleration using SSDs, fine-grained monitoring. Then in the HPC sort of work area, there is this whole question of I mean, Eric pointed this out, sort of accessing data from your workstation. That is a real issue. There is, of course, management. There are RAS features. Then on the archive side, this is a question we're only starting to look at, is the overall data management question, backup and replication, then links to a cloud environment. This is a project that we are actually doing right now, and then of course the HSM integration. And finally, in the business analytics world, sort of there is the connectors, like the Hadoop connector that Intel is providing. I'd like to discuss just two or three cases of these efforts and describe them a little further, and some of it has been presented already. So the large I/O patches, we started to look at them. I remember discussions 3 years ago. I said, okay, is it really useful? And it was tested at Oak Ridge, and it wasn't that useful for certain workloads. So last year we had a requirement at Nagoya University together with Fujitsu, where the requirement was a file per process workload from each core in the cluster. And this turned out to be most efficient from a pricing perspective with 3-4 terabyte drives, but then you ended up with several hundred threads per Lustre OSD, and we looked at benchmarks, and this is what we saw. So you go from 1.2 gigabyte per second per OSD to around 300 megabyte per second per OSD. At that time, we really didn't have a solution. Shuichi showed sort of results with the large I/O patches, and you see the blue line really makes a huge difference in the drop-off of performance when you go to a large number of threads. And in deploying the systems, we learned a lot about the behavior of disk systems, and including individual disks. For example, this is a comparison between a Hitachi nearline disk drive and Seagate nearline disk drives, and also the pattern looks similar. There are some differences. So here is a region where the Hitachi disk drives behave really differently from the Seagate disk drives, and it turned out that on a benchmark that was a 10% difference, which at the level of a storage system can be huge. This is the same data for read, actually. The next area I'd like to discuss is research data analysis, and I'll show one or two requirements, recent requirements around SSDs. So this was a recent requirement from an end user. It's a very bizarre requirement. It's output data from a simulation, and the requirement was, can we read a large shared file at 2 million 4K random IOPS? And the initial reaction was, you guys are crazy. Now it's actually possible. Since you're generating very little metadata I/O, all you need is a rate controller that can generate that many IOPS, and which is possible. And so we put together a solution. Shuichi showed some of this data already. This is sort of 1/4 of the solution, so 4 OSSs and half of the rate controller. Then yeah, you're already at 500,000 IOPS. 4K reads from a large file in Lustre. So these are things that are possible. Here is a sort of a different workflow that is it's a similar problem, which is you're reading the same data all over again because you want to compare one data set against a different data set, and even if you stripe your data, it doesn't really go well in a disk-based Lustre file system. So here is a version that we showed last year at SC, actually, where you accelerate that particular workload, so that particular comparison data set with SSDs, and you can see that your read IOPS you can accelerate it easily by a factor of 10 to 50 if you want to. And these workflows sort of in data analysis, I believe, are more and more common in general. There are many areas in the scientific world, not just genomics, but the seismic data analysis, various types of accelerators, large instruments. And there are then sort of data ingest problems, there are data management, and especially data retention problems. Especially the data retention problem is probably an enormous problem. And then, of course, data distribution and data sharing. And here I believe sort of the Lustre community still has some work to do. And if I plot this sort of in a more generalized fashion, so this is sort of the general high-performance computing type of workflow, large files, mostly write performance, mostly streaming, large data, scratch data, probably 100,000 of cores today, mostly InfiniBand, mostly single location, very limited replication. Extremely high efficiency. Meanwhile, sort of cloud computing is mostly small and medium files, mostly almost all read performance. It's tens of billions of files. We have one end user that is adding about 10 billion of files every day to one single shared file environment. It's mostly warm, or what I call worn data, which is read once, write once, and read never. And the number of cores is probably in some environments larger than in HPC, but it's still mostly Ethernet. It's highly distributed, highly replicated, and extremely low efficiency in some cases. So this data analysis workflows, I think it's somewhere in between these two cases. Here is, I believe, sort of the future of the near-term future of the Lustre efforts. especially within the NVIDIA will focus around. So these are the areas, not sort of, I think the HPC work area, it's not entirely solved, but we have a solution that works really well. But all these other areas, there is quite a bit of work to do. So the vision here is to get to a version of Lustre where we exploit the performance of all of the CPUs and the storage subsystem, both from a sequential and a transactional point of view, where there is caching at various layers in the data bus, where and there was quite a bit of discussion already, the single node streaming and small file single node performance is definitely increased from where it is today, where I can do millions of metadata operations in a single file system, which to some extent is already possible, and where I can do millions of random read and eventually also write IOPS within a single file system. And then also a version of Lustre where I do have data management features, including tiering, fast and efficient backup, data lifecycle management, easily available in the file system. And then the usability features like a better integration in a cluster environment, quality of service, director level quota, things that sort of people, especially in data analysis, want to have. And then for exploring Lustre in environments, say like a genomics environment where the IT staff typically has less experience, extremely high backend reliability for small and mixed size systems is, I think, still an issue. Now, all these sort of features or ideas that we're discussing are really ideas that do come from end users and end user requirements, and I truly believe that is the future. And also the Lustre user group is increasingly becoming a Lustre vendor group. The feedback from users, I think, is really, really crucial. And where I do see the role for DDN here is sort of in helping to translate user problems into roadmap priorities. And that, of course, is a work that has to be done closely in cooperation with OpenSFS, and we do work fairly closely with Intel, but also other players in the Lustre community. Now, that said, sometimes there are also weird projects. So this is Lustre on ARM, and if somebody wants to work together on that, I really like to. So raise your hands. Okay, and that's it. I do indicate that we are hiring, but that's probably politically incorrect, and I'd like to close my talk here.
Do we have time for questions if there are any? Right. Thank you, Robert Triendl.
Thank you.